So let's make this a practical application, because it's just easier that way. So here's what I've set up. Basically, we're going to take a milkmaid. This isn't the traditional one we have for the player. This is basically a clone, but it had nothing attached to it. Now, I've already added a NavMesh agent to it, which is basically what allows it to move along the NavMesh itself. This is all the areas that the NavMesh can traverse and look through to, move through. And as I said before, it comes with a lot of different options here. We have speed, angular speed, which I think is how fast it traverses up angles. Now for each object it has, or for the map itself, it has its own angle radius, angle height, max slope. These are the things that dictate how far of a slope you can go downward. So if I was to increase the max slope, it could go all the way down here if we wanted to, but that can look jank to a point, so I kept it at this one. I'm also going to turn our attention to, I've created these 3 points as well. So point 1, point 2, and point 3. So basically here to here to here is what I'm looking for. Now, like I said before, each one of these is just an empty game object. I've named them, but the only thing they're holding right now is positional data, rotation data, scale data too, but that applies to pretty much nothing as of right now. Rotational data does matter, but not for this. In any case, so what we're going to start off with is we're just going to try to make sure we can get the, I'm going to rename this as well, AI Actor. Fantastic. It's not static. Good. Okay, so we're just going to try to program her to move to the very first point. We'll start from that. That's going to be our first goal. Now I've already gone ahead just a little bit, but I figured I'd start here. So basically, I'm going to create a new script, and I've called it AI Character Move. I may rename it in the future, but that's also kind of a mess. So public void awake. What do you not like? Hold on. Which one do you want? Oh, right, because I didn't fit. Okay, so I'm referencing the player move script as well, just to make sure I have everything right. Right now, what I'm trying to add in is game object points. Now, this is going to be our array in the future. It's not currently an array. To make it an array, you would need to add the brackets here, which basically says that it's going to be an array of game objects named points. Now, I'm not 100% sure on how the naming will go for each one of those points. I think points, an array, when you reference them, you can do points .1, .2. I'm not 100% sure. We'll have to figure that one out because I don't work with arrays a ton, but there's a time and a place. In any case, the next thing, first we're going to take that out. The next thing we're going to do is we're going to reference the NavMesh agent. If you look over here, the NavMesh agent we have is the player nav. Now we have that set to private because here we're just on the very start of the program starting up. We're just having NavMesh agent look directly for NavMesh agent as the component for getting it. Now it's not got any name to it. Usually we do like NavMesh agent dot something, or you'd reference a name in here. We don't have that in here because there's currently only one, and it's the player character, so it just finds it instantaneously. So what I'm going to need to do after that, or after I write this program, since there will be at least 2 NavMesh agents, I'm going to have to make sure that there's name distinctions in each of these things here, in these starts. But in any case, so we're going to define what the NavMesh agent here is, because we're going to directly reference it for coding. Now, it's not going to work right now, because if you look up here, these are all namespaces, essentially. These are all namespaces of current programming libraries that can be referenced and used in code. So you see things like public, game object, mono behave, like all the stuff, even void update. If you think about code, code's basically just, I mean, there's a history, but you could boil it down to ones and zeros and just sort of work up from there. Reason why coding has gotten so much easier is because all the programming, all the basic level programming has been done, it's been built up. We don't have to talk directly to the machines anymore. We talk to libraries, essentially. And with Unity specifically, they have their own libraries that talk directly to them. So when you're talking about C++ or C# as a language, you usually have to bring in your own libraries. But thankfully, since we're working with C# for Unity, we're working directly with the Unity library, which is why Unity, or using Unity Engine, is just a namespace library for all the stuff. And let's take a look at this real quick. Go to definition. I don't know. Go to reference. Go to base. I don't know which one's going to take us there. I don't know if any of them are going to. So anyway, it doesn't matter. It's just gonna pop up with a lot of code. Let's see if we can go to any of these. Oh, sweet. Okay, so yeah. So this is all underneath the class just for game objects. So that one thing which helps us just sort of define the type that we're going to be working with in that one thing is pretty much this. It's this entire block of code, which allows us just to reference a game object within there. But considering I don't want to program all this just to communicate with the engine, and they've already done that, we're going to instead use this library, or this class within a library, to program what we need to. So this is all I have to program because the library has already defined everything for us, which is super nice because I am not that smart. Now, the point of that is that there are several different libraries that we have to add depending on what we're using. In this case, UnityEngine.ai. We want to import the AI engine. And the reason why you don't just have the entire libraries like constantly linked to every script is, I mean, if you imagine it, you're trying to look up a word in a dictionary, and the easiest thing that you could possibly do is just look directly at the word you want and find the definition. You don't want to have to read up every single word and their definition just to get to wherever you want to. So you're just packing yourself full of stuff that you just don't need for what you're looking for. So that's why we only bring in one thing at a time, essentially. And it's saying right now it's unnecessary because I'm not using it at all, because it's smart like that. But I will be in a moment. Nav mesh agent. Fantastic. And see? Fantastic. And we'll call this AI test for right now. Cool. Now you can see it recognizes we're using it. Now, system collection stuff. This always comes default, and I'm gonna be honest, I haven't looked into them too much. Collections stuff usually is pretty good, because when you're talking about like data collections or whatnot, it's one of those things that's currently way above my head, and I've been busy, so I haven't taken the time to look through it. But I mean, why not? Whether or not I'm using it or not, I don't imagine it's too bad. So what I have here is just my points and my agent, my character, essentially. So what's going to happen here is I'm going to try to get my character, the nav mesh agent, which is, if we go back, this character, this is my nav mesh agent, and I want her to go to point 1. So I want to transfer her, not transfer, I want her from this position right here to point and direct herself to this position right here, because I've set that up over there. Now, what's wonderful about Now, what's wonderful about this is that, God, what was I saying? Oh yeah. So what's wonderful about this is that there are, within the nav mesh agent class, there are things that we can use, same things within libraries. It's just stored in functions that already have definitions, already have programming attached, that we can use to affect this nav mesh agent, or anything in any case. Like GameObject has the same kind of stuff. Anyway, but what I'm talking about is this bit of code right here. Set destination. So, I mean, honestly, here's what we're going to be doing. We're going to be taking the player nav, or I'm sorry, we're going to be doing our AI nav. We're going to do a dot set destination, and this is basically where we define the position itself. In the player, it's, well, actually, this is strictly the interactable thing, I think. Anyway, this is the position at which the point at which the player model was transforming to. In our case, we're just going to be moving to points. In this case, it's not an array yet, so it's going to be real simple, and I will show you once I complete this code. So on awake, honestly, I'm just going to do this on awake. We're going to go AI underscore test dot set destination points dot transform dot position. You happy with that? Good. Alright, so it's just basically I am setting the destination for the character through the set destination function, which, let's have a peek look-see at that, because that's always fun. Oh, that is, it's deep. Layer cost, set path. There's a lot. So this is it's layered, it's complicated, it's fine. Anyway, but yeah, I'm setting it to that destination. So let's go ahead and save it. I'm going to leave updates here because I'm definitely going to be using that in the future of this script. We saved it. AI character move. So take the script, AI character move. We're going to drop it into here. Now you'll notice these two things have popped up. I can make this easier on myself, and I'll show you how. So the reason why these two things popped up, it's a clever little way that Unity has their system built, which is super nice. When you're declaring variables appear, and variables being anything, like when you talk about variables, normally you're talking about ints and floats and stuff. I'm still going to call these variables. But when you declare them to be public, which means that they can be affected from any script and from anywhere, that means they're, you're able to see them. Your whole program's able to see them, and well, that's pretty much it, isn't it? Now, the antithesis of that would be setting them to private. Now, that means that only this script has the ability to access and modify this variable. So if I, say, wanted to attach another script, and I don't know if I have any of those up right now, a script that is taking anyway, yeah, okay, so in this case, check this out. So door open is drawing its script from the interactable script, which comes with these variables, which means that since door open is drawing from the interactable script, it will also bring in these variables into there. Now, say I have, do I have any private? I don't have any private variables in here, but if I had private variables, that means that they would not move over to here to be edited as well. In any case, the reason I'm going to set this to private is because there's really no reason that anyone else is going to have to see this going on, because I don't need to drag and drop it. It's just going to be this model that I'm attached to. I'll show you what I mean. AI test. So there's two functions that deal with these programs. It's void start and void start. Oh god, okay. Void start. Now, void awake and void start, one key difference, or the key difference between them, is void awake is all this code is activated the moment that the script itself is called upon, which is different from void start, which is all this code activates when the program starts. Once the script is loaded in, it loads in all of this stuff. Versus void awake, which again loads all this stuff once the script is referenced or activated. And you know, in this case, actually, it would be better to put it in a start. The reason being is because if you already load in all the stuff that you need to when the program starts running, even if you're not using it at that moment, that means that when it's time to activate it, you don't have to go through the process of loading it anyway. So we're going to go ahead and transfer it over to the start. Okay, cool. I'll be honest, I don't remember why I told you that, but I think I'm just rambling, so we're going to move on. AI test is going to equal. So before, when we had this system, what you would do is you would take something. It would have to be a nav mesh agent. So what it says nav mesh agent here, or game object is pretty much referencing anything. It can be almost anything in here, except for maybe particle systems, whatever it is. This gets pretty cool, and I like this a lot. But in any case, since this is nav mesh agent, it's looking directly for a nav mesh agent. So if I was to drop this in here, I could drop this in game object because it is also game object, but I cannot drop anything else into nav mesh agent. Event system doesn't have a nav mesh agent on. Water, sound, nothing. But the player character has a nav mesh agent, so we could drop that in there. But the point of this is we want to get this in here, and also, you know, essentially we want it to look like this. But in any case, we're going to bypass a little bit of this. We're going to immediately, when the program starts, define exactly what we're looking for. We're looking for AI test equals this dot game object. I'm pretty sure that'll cover that, right? It won't cover it. Game object 1, 2. I don't imagine you do this. No. This dot nav mesh agent. God, I want to do this dot game object, but I can't do it, can I? Okay, what's saying? Nav mesh agent. Unit game object unity. Dot. Nav. Oh, dear Lord. Okay. I know we can. We've done it before. Private nav mesh agent. Oh, yeah, I guess Alright, we'll do it this way. We'll do it this way. Dun 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 dun. Get component. Nav mesh agent. Dot this. Oh god, I want to use this. This. Maybe. I wonder if it'll work. Let's test it out. Alright. Big component. So you gotta save, otherwise it's not gonna send the changes to Unity. Okay. Oh, cool. It does work. Alright. So basically what that's saying is this is basically a reference directly to whatever the script is attached to. So when I say this, I mean you're looking directly at this character. When you say get component, you're looking for a component everywhere. When you say this, you're referencing the thing it's directly attached to. So cool. Good. So right away, it already knows we're looking at the AI character move. But we're not. But we're not. We're not looking at the character move. Oh, okay. Alright. Fine. I wonder, what's it going to look for when it gets to that point? Let's see. The point of me doing this is to gain maybe some self-appreciation for how struggling this can be sometimes. You think it's going to go one way. Maybe I'm just getting fancy. I mean, I am getting fancy, but this isn't really that fancy. Dot. No. Alright, you know what? Fuck it. Fuck it. Fuck it. For right, we'll just leave it at this for right now. Just for the point of testing. We'll just leave it at this. Wait for it to load. Wait for my gig of RAM to catch up. Don't be like this. Oh, it's still private. God fucking damn it. Cool. What movie is that? It's oh. No, I'm an idiot. No, I'm an idiot. I'm an idiot who doesn't sleep enough. Oh, okay. Never mind. Tell you what, we'll go. We'll go public. One thing I'd have to say that makes this system not always the greatest is that setting it to public or private has a real use within actual programming. The thing about Unity is that it also uses it as this visibility point. So I wish I could do both. I wish I could set it to private as well as still see it within the inspector. But let's see what it points to in public. Yeah, no, we're good. That worked the first time. Awesome. All right, well, so here's what we got. We have defined what the character is moving. We've defined the point at which it's moving. And then we're setting its destination to there. Fingers crossed, I don't mess this up. Let's see. Oh god, did I turn off the volume? Hold on. I did not. Hold on. Stand by. Switch off Wise for a moment. Okay. Cool. Back to scene. Yes. So good. We're there. We're there. We are there. Let's... Is that too fast? That's pretty fast. Tell you what, let's set their speed to 2. If you notice. Get it that nice, that game realistic healthy. It's too fast for walking characters, but too slow for running characters. Just that right amount of annoying. Ugh, perfect. Alright, perfect. So we've made it happen. Alright, so that's essentially it for just making them walk from place to place. Let's go ahead and I think I like 1.8. Let's go about that for speed. Stopping distance is 0. Let's go back. So let's figure this out. Let's go to 63, 20. All right. 63, 20, 137. Now remember I said something before along the lines of making sure that the player character or the character gets to the exact spot and how it's not an exact science. So let's let's take a look at that real quick. So we're looking for 63, 20, 137. Yes. Yes. 63, 20, 137. See that? There comes a point where, I mean, here's the problem with this too, is that it's always gonna be stuck to there. Now, it's pretty good actually. Why? It's probably because it's actually floating right above. Yeah, that's why. Yeah, so it's going to go to the position it thinks is best for the nav mesh agent itself. Anyways, I mean, that's pretty exact. I guess the nav mesh agent, we'll deal with that. I still don't think that having our codes run on, hey, have you reached this exact point yet? Okay, now let's move on to the next task is so much the best idea. I still don't necessarily think that. But maybe we'll give it a shot. Okay, so the next task at hand is game object array. Now we're going to have an array of game objects, which is going to make this code break, essentially, because we're not dealing with one object. We're not even dealing with an object at this point when we're referencing it. We're dealing with an array. An array does not have a transform. Array is something else entirely. So, dealing with arrays. Here's what I'm going to have to look up. And this is the next best. Might, and usually sometimes does not. So, Unity array. Scripting, arrays, blah, blah, blah. Sweet. Okay, we're looking at examples. What I'm looking for specifically right now is how to reference positions in an array. And this is all basic array code, essentially. Push, pop, move last member array, returns, yeah. What value 1. Okay, cool. So it's just basic array stuff. As if it would be anything else. Okay, cool. Set destination. So here's what we're going to do. So actually, I'm going to give this, I don't know, maybe this will work. 1. Oh, wait, no. Whoopsies. Whoopsie doopsies. Whoopsie doopsies. Alright. Yeah. All right. Cool. So basically, here's what it's doing. I've created an array, and I'll show you how this works in Unity in just a second. But it's going to have 3 points inside of it. Ooh. I'll get to the second. So it's going to have 3 points inside of it. And what this is doing is saying, I'm going to take point... Back up. It's going to have 3 game objects inside of it. And game objects will always have transforming data. NavMesh agents don't have transformation data. So that's why I can't reference the transformed opposition, which is exactly what we need to move to a point. But this stuff does. So it still works, I guess. What the mistake I made here was arrays, or code for that matter, counts from 0 up. So I'm not looking at position 1, I'm looking at position 0. Now we're going to this. Now, let me show you how this works in Unity. Points. We're going to have 3. So here's how arrays work. Arrays, when you do it, it creates this drop down, and then you can select the size of your array. You say 3. You can also say 20. And, you can put anything amount in there. You can put anything in there. We're only going to have 3. And we're going to have 0.1, 0.2, and 0.3. Here's something cool. I turned off Y is global, and it didn't like it, so it created a new one, which I'm okay with, I guess. I wouldn't want to have to. It's fine. So here's our points. Now, all things said and done, we're still pointing to the first position, so this should still work. Bless me. Get it. Come on, get it. Get it. Get there. Where's she gonna end up? Let me see. Yeah. Okay. All right. Tell you what. We'll go the risky route. For right now. So we're just slowly building up to what we want to do, which is the full, anything. I mean, honestly, it's kind of obnoxious sometimes to program because you just sort of figure out little things you want to do in the middle, and then you're like, oh, I'll restructure everything. That's why it's good to come up with a plan. But I don't know. There's a weird sort of fun that comes with actually being able to do things right. Like, I could do anything. I could do whatever I want to. We'll get there too. Nice reflection probes. Alright. Cancel. Bring it back. Now, here's what we want to do. We want to switch the destination from point 0 to point 1, and then after that to point 2. So, we can do this a couple different ways. We can go with the original plan of having a sphere around here that basically triggers when the player enters and then communicates with the player character, or sorry, not the, which communicates with the character and says, hey, we're no longer following 0, we're following 1, and switches her main transform or main set destination to the next dot. Or we can, within this code, say once you've reached this destination, switch to the next one, or add 1 to the array to switch to whatever's next on the array, which is probably what we're going to end up doing. Since we also want to go back, we also want to -1 from the array. Now, I don't know how easy that's going to be. We'll have to reference this again. Let me double check on this. No. Adds value to the end of the array. Don't want to do that. This isn't what I'm looking for directly. So this doesn't have my answers. Anyway, the easiest way, the easiest to do, but perhaps not the most efficient way, I think, would be to have all right, this is complicated for a couple reasons. The easiest way, as far as programming, I think, would be to make the trigger volume and just have the script switch out which point you're currently going towards. The next easiest... not the next easy. The reason why that might be better is because when you're dealing with trigger volumes, it's only checking for when the NavMesh agent, or rather for when the game object enters its sphere, and thus it saves on updating because it's not updating every single frame. It's only updating once these two things come in contact with each other. Versus this script having to constantly update, meaning it's checking every single frame whether or not we've reached this destination, and then checking every single frame again to see, for when we reach the next destination. It would be constantly updating. Now, we could slow down the update with fixed update, or I think that one calls every other frame or something like that. And when I think about it, I mean, if we're going to be switching out, because start just starts right at the beginning, if we're going to be switching out these values, it might... might be doing that anyways. Let me see if something works. I'm going to do this. I'm going to go ahead and create I'm going to go ahead and create another variable. Public. And this one's going to be an int. It's going to be an integer. And we're going to call this point number. Now, here's what this is going to be any whole number, essentially. What I'm going to do is, since zero, all this is asking for is a number inside of it. Point number we're going to replace here, because what's going to happen is I can Father of mine waiting anticipating I can, here we go, see, this is also public. I can just set this number to pretty much anything. I can set it to 6, but I only have 0 to 2 right now. So we're on 0. Let's switch it to 1. Let anything. Switch it to 2. Do nothing. Alright, and so that confirms what I thought originally, which is I'm gonna have to put this in update. But I don't think I have to update every single frame. I could probably do this with fixed update. Fixed update. That be capitalized? Of course it does. Of course it does. Fixed update is called every fixed frame rate frame if the mono behavior is enabled. So this means it's not as taxing. It's about half as taxing as update. Let's go ahead and try it out. I've had Mulan songs stuck in my head all day. Strength before the chorus. She is grooving. Look at that. Let's go for it. 2. Heck yeah. Heck yeah. Oh yeah. And go back to 0 though. But why not 1? Why not 2? Oh yeah. Oh, it's working. Oh, it feels so good. Okay. We're gonna also do a couple obstacle avoidance. These are some other things that auto braking. There is something I'm sure that affects how fast she turns. I wonder if it's this. Honestly, I'm kind of wondering if it's this. 3. Oh no, I don't have 3. 2, 1. Oopsies. 0. 1. 1.8. I don't think it is. Let's go to 1. It seems about the same. Anyway, I mean, that works. Perfect. It just has to be in the update. Okay, cool. Okay. So. Now here is my next thought process. What I'm going to have to do is take the nav mesh agent, not the, okay, I'm going to have to take this game object, the one that, this one, the AI actor, essentially. Take its game object, which has its transform data, and I'm going to have to then take the point that it's currently referencing, which right now is points pointing directly at what number in the array it is, transformed opposition. I'm going to have to compare the two and then say, hey, if this game object, if the AI character's game object has the same transform data, all the same numbers, as the points in which the points in the array, then we can activate the code to let it switch to the next one, which in this case doesn't help us if we want to turn around, unless we specifically program in, like, on this set point, if, you know, we reach a certain level in the array, then from there we start minusing off. But we don't want to do that. We don't want to do that because if we put that into the code itself, then that means that no matter what object we attach to, because remember, we're building this for all AI objects. We're not just building this for this one character. If we put that hard limit in there that says, hey, on this specific array number, we start minusing down, that means we only have to that number, and then it's going to circle back. And sometimes we don't even want that to happen. So you want to leave it as open-ended as possible. Which means it may be more beneficial on the very last node that we have to have a trigger volume inside of it of some kind that says this is the end, switch them back. I don't know if that's going to be the most efficient way of creating it, but we'll figure it out. Okay. Well, for right now, this is what works, and we can link these up right now. So here's what we're going to do. We're going to create... Should we create a function? Should it be within a function? Yeah, I think we can be. Okay, so let's say this could be private, void. This could be public, because we may actually. No, we have no reason. Okay, so this is going to be private because we have no reason to actually affect what's going on in the script. We are going to be affecting this number directly if we're going to be switching them around. So that's going to be public. The function can be private. So private, we're going to name this function destination. No. I had a teacher in college that would stress more than anyone else about what proper naming conventions would be like. He would constantly try to read it. Like, he would spend a few minutes every day for each function that he create, just trying to think of the best, most logical name for each of them. And I'm just like, fucking name it points, destination switch. Fuck. All you would spell it wrong. Fuck it. Switch. Alright. Private. What? Void. Okay. Because it's not returning a value. Will it be returning? It won't be returning a value. We're actually just making sure that we can keep up on... Well, we are going to be returning a value. Sure. Tell you what, I usually don't do this, but let's give it a shot. Not all code paths return a value. Fuck does that mean? I'm just looking at this like it's a fortune cookie. Like it's trying to teach me a life lesson. Whatever. Okay, whatever. Look. I've already been working all day. I'm already tired. I'm amped up to do this, though. You may not know this, but this is going on day two days of me recording stuff. I mean, 2 days of me trying to work on this thing, thinking it out. And it's admittedly taking a little bit longer because I'm trying to explain everything, but I want a teaching tool to sort of enhance myself and make myself better as well, so, you know. Anyway, destination switch. So what we're going to do is this is the code we're going to be using to calculate what the difference between the two values, and figure out when it actually reaches its destination. That's what we're trying to say. Now, okay. So first thing we're going to do is let's go with my gut feeling. So if I'm going to say if this dot transform. Remember, this is just referencing the game object that the script is attached to. Transposition. Oh, I did spell wrong. Position equals, and we got points dot. Wait, no, I'm sorry. And then so what we're doing is we're referencing the let me just type this out. What we're saying is well, actually, what we're doing is referencing the exact point in the array that has the game object, and we're taking that game object's transform data and comparing that game object directly to this game object to see if it matches. Now, I have a problem with this. The reason I have a problem with this is that the nav mesh agent is so very specific. Not specific. It has the character. It has the character attached to the ground. Where's my character? It has my character attached to the ground to the point at which it can actually use it. Now, I can try my butt off to make that happen here, but the fact of the matter is these are hand placed. Now, it makes the best guess it can for the X, Y, and Z values. Now, it can't jump. It won't go to the Y, but the X and the Z values, it'll certainly coordinate between those to give me the exact point on here it can go to. If I say that I want it to be the exact transform position, then it's going to mess up solely on the fact that it's never going to reach that Y position unless I'm so exact, and I don't want to do that. That's silly. Now, what I can do is define if I want to do it by the X, X, Y, and no, I can pick one. Now, I can do it by the X and the Z. Okay, here's what I'm going to do. I'm going to do it by the X. It just seems like a lot of code, but whatever. I'm going to copy that out. So here's what's happening here. The two equal signs indicate you're doing a comparison, whereas one equal sign is you're actually changing the code. You're basically saying like this now equals this versus check to see versus you're just comparing these two numbers. And this is how you do all if statements. It won't let you actually change the code within it itself. You have to do that within the function itself. Now, we have the AND operator as well as the OR operator. In this case, we're going to be using the AND operator, which means that it's asking a simple question. If this X position is the same as this X position, and this Z position is the same as this Z position, then go ahead and do this thing. And that's what we're going to be doing. So here's what we're going to be doing. We're just going to be, for the time being, adding 1. This isn't going to solve anything for the long run. And again, what this is going to be doing is it's a little bit of the same flavor as before. An equal sign means that point num In this case, if you just had the equal sign, it just means point num would then now equal 1. But in this case, we're adding 1. So point num plus is, you know, it's just the way the engine works right now. Let's go ahead and test it out. Hopefully it works. I don't see why it wouldn't. And that's the kind of confidence that makes you really frustrated when it doesn't work. Because I don't know how this would fail. Okay. So now, basically what we're doing is we're just looking at the X and the Z and ignoring the Y. Now, once we reach that destination, they're exactly the same. Okay, all right. Well, oh, because I'm an idiot. God damn it. Well, here's the thing. I have the function, but nowhere in the code do I actually tell it to run the function. Because this is where the magic happens. So that just means all I have to do... Okay. Let's actually do some array switch. Sure. Array switch. Oopsies. Yeah. Now we're telling it to run the code, or to run this function within the update. Fabulous. All right. Cool. And we wait. Okay. Come on. Come on. Every single time it's like watching your kid try to accomplish something. There it is. I say that like it's like watching your kid like up to bat to hit his first home run, or yeah, baby. We have done it. Now watch what happens when we reach point 3. Well, come here. Wait. Yeah. Nothing. Stops there because, you know, now it's set to 3, which is technically the 4th object, and there is none. We could set one though. Watch this. 4. And now let's make it to 0.1. Well, you know. Oh, because, whatever. Anyway, you get it. Very fucking cool. I mean, here's the thing. This is all really simple. Make a big deal out of it because, you know, everything takes so much thought. And it's hard to do. But it's really intriguing as to how you think about things. Now, here comes the fun part. And that's another thing I probably say too much. Well, I guess I guess what we can think of is this. When we look at what a character is doing, what are some things that make them more natural? Because they're not just walking around, you know. Characters, people don't just walk around aimlessly doing stuff. Now, that's why we have things like the cow states, and I don't want to bring up the cow stuff right now, but you know, that's one of those things where they have several different things that they're doing depending on what their script is wanting them to do, depending on where they are. They have things that tear them away from their traditional movements, and that's the kind of, you know, AI that you need to be looking for. Right now, this is just moving from one place to another, but just imagine what people do. You know, if you're walking to one destination, what are you doing when you're doing that? And that's a wonderful study as to how the human mind works and why we don't see video games as the ultra realistic part of our lives that traditionally, you know, you'd reserve for normal human interaction. Which is why when you see video game characters, you know, acting human versus, you know, acting extremely grandiose, or you know, like, but between Call of Duty characters and any Naughty Dog characters, like, even some of those guys can be braggadocious, grandiose, bombastic, crazy, doing over the top stuff, exhibiting bravery that, you know, humans would flinch at it. But sometimes, you know, these characters, it just seems not real, in the sense of, like, it's a fantasy versus when you see a genuine character doing genuine things. Now, I mean, that level of detail is a lot of the time unnecessary for the scope of the project that you're trying to work on, and, you know, can be a massive detriment. Well, not a massive, but it can be a detriment to what you're trying to convey. Because if you have, you know, a character who is scared like a normal person is, or a character who flinches, or a character who undergoes the same mental, you know, capacities that normal people do, it can harm the overall sort of vision and expression of the story you're trying to tell, because you're trying to convey a character in a setting through that emotion. My point of this is that, you know, when you have the ability to look at your surroundings, it makes it... Well, let me back up. When you have the ability to try to replicate reality, you look around and you kind of appreciate more the things going on around you, because in a way you can see how much more complicated every little thing is and how much there is that goes into everything. I mean, especially with animations, right? Facial expressions, body movement. I mean, everything is ridiculous. But same thing with programming. In a way, I mean, maybe I just feel that way. It's kind of nice. But my point of that is when we're looking at the natural movements of a player or a human, I mean, depending on what their personality is will also determine that too. So maybe this character will wander off, look at a pond, touch some grass, sort of yell at a goat, you know, whatever. Maybe admire the sky, break into a run every so often. And these are the things we added in between. Now, I'm not saying we're going to add all that stuff in, but that is the kind of thinking I'm looking for. Oh, hi, dog. What? Oh, hold on. Now, I'll leave it off on that for right now. So, here's what we've accomplished. Bursty, bursty, burst. Horty, horty, hor. By the way, if anybody's actually watched genuinely this whole thing, I mean, first of all, I'm sorry. But that's what it's like constantly. You look at previous code, you look at things on the internet, you frustrate over little minutia. I mean, it took a long time to get to, well, not long, it took a lot of work and a lot of repetition to get to the point where I kind of have an idea of what I'm going to do before I'm going to do it, and even then, you sort of realize things that you didn't think of beforehand that you start to think about. Let's go over where we were now. So, we have a code that gets us from one place to another seamlessly. Now, one thing I'm going to do is we're going to set this to 10. Accelerate. Psh. 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 That's just too fast. Let's set the acceleration to 12. Let me think. Let me think. Is that a run? Is that too fast? Is that too slow? It's probably a little too fast for a run. God, I wish she turned faster. I know there's a way to make that work. We'll explore that more in depth later. Okay. So up next is going to be we're going to whiteboard out some more stuff as to what we want to add in between. We're going to we're gonna switch. We're gonna make sure we can track the end of the array. Actually, I think we can do that by length. I think we can track the end of the array. Now that I think about it, we can definitely track the end of the array. And that whole wondering what to do thing was for naught. And then we will we'll work on ideas that fit well into a universal AI script. So something that can apply to everything, something that gives us a lot of options. We don't have to use all the options for every single object or every single character that this is applied to, but it's good to cover all the bases so that when time comes to actually use the script on something, we will have everything accounted for and not limiting itself. Alright, well, I mean, I'm going to do this again tomorrow and every day, so, bye.